Hi students, and welcome to video number 5 in the Preliminary Chemistry Chemical Earth series. In this particular video we're going to be looking at how we assess different separation processes. Now up to this point we've kind of looked at the different spheres and the mixtures of materials that we find in each of the spheres. We've also started to have a look at some of the different ways that we can use various separation techniques to separate the components of different mixtures. And we know that our separation techniques are linked very strongly to the properties of the components. So what we're looking for is a difference in the components of different mixtures. So that's what it is that we're going to be doing in this particular video. We're going to be looking at some of the key separation techniques and exactly what properties of the components are useful when we're using that particular separation method. So what I want you to do is perhaps it would be important to set up a comparison table, for example, which I'll give you an example of on the next slide, to help you to identify what it is that is key for each of these different separation processes. So here's a little bit of an overview. And you can see that I've put on one column of this table a range of different separation methods, from sieving to evaporation, magnetic separation, distillation, and so on, to just give you a bit of an idea of some of these different types of methods. Now, the important thing is that you're able to go through each of these methods and identify the property that's used in the separation. So if we're sieving, for example, we've got maybe a metal plate with holes in it, then the key property is the size of the particles. What we want is two different or multiple different substances, if you like, which have different sized particles. So some of the particles will fall through the gaps, they will be small enough to pass through the holes, and others will be too large. And in that case, we have two different groups of things being separated on the basis of the size of the particles. So that's what you're looking at for each of these examples. For evaporation, the differences are based on differences in boiling point. So for a solution of salt water, for example, we know that the water will boil at a lower temperature than the salt, and so therefore evaporation allows us to remove the water and keep the solid behind. Magnetic separation also works on the property of magnetism. Distillation works on differences in boiling point. The difference between these two is usually that we want to recover both of the substances. In evaporation, we just allow the water to dissipate, to go into the atmosphere, whereas with distillation we actually want to keep the two liquids or the two substances together. So you could still do salt water, you'd end up with salt on one side and water on the other side. Fractional distillation is basically the same thing, so it is differences in boiling point, but usually those differences are smaller, and the number of substances you're trying to separate is much larger. So this happens particularly in things like crude oil, where we know there are a number of different fractions, a number of different types of materials, and what we want to try and do is separate each of those out, and we know that just some subtle differences in their boiling points means we can get each of those substances out individually. Filtration is based on solubility, the fact that certain substances will dissolve in water and certain substances won't. A precipitate does not dissolve in water, and therefore it will not pass through. Again, it's an issue of size. The particles of the solid will not pass through the filter paper, whereas the water and any soluble particles will actually pass through that filter paper. Separating funnels based on immiscibility, so that means that two liquids, when you put them together, do not mix. Oil and water is one example. So we also want to make sure that there's a difference in density so that one sits above the other. So for example, our oil is sitting on top of the water. In the separating funnel, we can open the tap, allow the water to run out, close the tap when the oil reaches there, and then we've got our oil in our funnel and our water in our separate collecting device like a beaker. And finally, chromatography is again related to size, but in this case, the size is the actual mass of the particles, not their surface area. And in this case, it's important that whether we're looking at a solution or whether we look at something like gas chromatography, that the particles will actually move faster based on whether they are large, massive particles or very small particles, and that will create a separation. So the important thing when you're looking at separation techniques is that you can think about what property of the substances or of the components of the mixture is critical to the separation method, and why have we chosen that particular method. Thanks for watching.